Hello grade 10 students. Today I am going to teach you all friction. This is the 5th lesson of your grade 10 science textbook. And as you know, this is also a physics unit. Let us think about why we need to know about friction. Let's say you're walking on a normal floor. You can walk without slipping. But if there's water or if there was a little bit of oil on the floor, then there is a possibility that you will slip and fall. What is the reason? Now I am holding on to this pen. It doesn't slip off my hand. If I had oil on my hands, this will slip off. So here the factor that helps us to hold on to things, walk without slipping, and even for vehicles to drive without skidding off the road is friction. And if it is not there also, we will not be able to do certain activities. So therefore, friction is a concept that is very important in motion. It is related to motion and it is important. At the same time, it can become a problem to us. So let us now look at the topics that we are going to discuss under this lesson. Nature of friction. What friction is? Static, limiting and dynamic states of frictional forces. The 3 types of frictional forces. Factors affecting the limiting frictional force. So if we know the factors that affect frictional force, we will know how to change it. Practical applications of friction. As I said, the uses and the disadvantages of friction. So with that, we will go into the lesson. We will start the lesson by discussing nature of friction. Nature of friction. Now this is something that you would have done in the classroom very frequently. When you are listening to a lesson, you try to move your pencil or pen. You just roll your pen or pencil along your table. So what happens when I place this pen on a table? I give it a small push. It will roll to some distance and then it stops. Now if we apply a force and the pen starts to move, according to the Newton's law, you know that very well, when there is no other force acting, this pen has to move continuously. But from the observation, we know that the pen stops. That means there is another force opposing the movement of the pen. Let us consider this example. Now let's say there is a surface. As I said, there is an object here. And when we give a force, the object is going to move in one direction. So this is a moving object. But with time, it slows down and stops. So here the observation will be moving object slows down and stops after some time. What is the reason? Now if you look at this diagram, the object is placed on a surface and there is contact between the surface of the object and this surface. And what happens is this surface always tries to oppose the motion of this object. So for that, the surface in contact applies an opposing force. So when this object is moving, the contact surface is exerting an opposing force. This is a resistive force which is trying to resist the movement of the object. That is the reason the object moves to a certain extent and then stops. Now let's say we move this or we push this same pen with a higher force. So what will happen? The pen or the pencil will move again and it will move for a longer distance than the first instance. But still it will stop after some time. Same way, we use a different surface. A surface that is even more smoother than the table. Let's say a nice shiny tile. If you roll the object, the pen or the pencil, there also it will move. But again, it might move for a longer distance, but in the end, it will stop. So the reason for the stopping of this object is a force that is opposing it. And that force is exerted by the contact surface. The contact surface applies this opposing force. And this is what we call as friction or frictional force exerted by the contact surface against the moving object. So one feature or one nature of friction is that it tries to oppose the movement of a moving object or oppose the motion of a moving object. So one thing, the frictional force or friction opposes the motion of a moving object. So that is one nature of friction. Now let us consider what happens to objects that are at rest. So students, as you can see in this picture, there is a table at rest and the boy is trying to push the table. When he pushes the table with a small force, the table will not move. What is the reason? There is a force applied in this direction, but the table is not moving. You already know if an object has to move from rest, then there should be an unbalanced force. We apply a force, but unbalanced force is not there because the flow is exerting a force that is equal to the applied force and in the opposite direction. So here what will happen is the flow will exert forces in the opposing direction. Opposing force. So what happens is the applied force will be balanced by the opposing force. Let's say we increase the applied force. Then also the table will not move. The reason is the opposing force, that is the friction, will also increase. Thereafter, if we increase the push to a very high extent, to a very large force, then obviously the table will start to move. The reason is there is a limit to the opposing force that can be exerted by the flow against the movement of this table. So students, you have to understand there is an object at rest. The object is trying to move and the flow is trying to stop it by applying an opposing or resistive force. This is what we call as friction. So, friction is the opposing force that is exerted by the flow. And when we increase the applied force, the frictional force also increases. But it can increase only to a certain limit. Once the applied force exceeds the frictional force, the table will start to move. So, this is another feature of friction. So, I will write that down. Initially, applied force is equal to frictional force. Then no movement. But when applied force is greater than frictional force, the table moves. So, we have looked at the nature of friction. When an object is moving, the contact surface exerts an opposing force or a frictional force against the movement of the object. And here, when the object is trying to move, so here object is trying to move, the contact surface applies a force against that. So here there are two instances. One is the moving object, the other one is the object that is trying to move. And under that also we saw that the frictional force can increase to a certain level. And thereafter it cannot increase anymore and the object will start to move. So, based on this, let us now define what frictional force is. The forces that act between the surfaces of two objects in contact with each other to oppose the relative motion when the objects are moving relative to each other or to oppose the tendency to move when the objects have a tendency to move relative to each other are called frictional forces. So, this definition includes both the examples that we discussed before. Let us look at the first part. The forces that act between surfaces of two objects in contact with each other to oppose the relative motion when the objects are moving relative to each other. So, we saw the pencil being rolled on the table, a rolling pencil. So, it's a moving object. So, there are two surfaces. Both the surfaces are moving relative to each other. The pencil is moving relative to the table and the table is trying to stop it. That is what we say objects are moving relative to each other. And the second part, to oppose the tendency to move. When the objects have a tendency to move relative to each other. The table has the tendency to move relative to the flow. So, there when it is trying to move, the flow is exerting the frictional force. So, this full definition includes both the examples that we saw before. The forces that act between the surfaces of two objects in contact with each other to oppose the relative motion when the objects are moving relative to each other, or to oppose the tendency to move when the objects have a tendency to move relative to each other, are called frictional forces or friction. With that in mind, now let us look at the different instances where frictional force acts, or the three types of frictional forces related to movement of objects. Static, limiting and dynamic states of frictional forces. Frictional forces can be divided into three categories depending on the situations they act on a body. And they are: the first one, the frictional forces that act when there is no relative motion even though a force is applied. When we push a table but it does not move. So, there is no relative motion even though a force is applied. Okay. So, when we push an object but the object doesn't move means it is this type of frictional force. The second type, the frictional forces that act on a body as it just begins to move. When it just starts to move. So, we pushed the table, it did not move, first instance. We increase the force, then the table starts to move. That is the second instance. Let us look at the rest of it. This force includes the small additional force that is necessary to give it a velocity. When we push the object, we push with a higher force so that the object moves with a certain velocity. The third instance, the frictional forces that act on bodies when they are in relative motion. That is the first example. When a pen was rolling on a table, there was friction being exerted by the surface of the table. So, that is the frictional force exerted when they are in relative motion. So, these are the three instances in which frictional force acts, or the three states of frictional forces. I am sure you would have got a good understanding of what these three types of frictional forces are. Now, let us discuss an activity to demonstrate the three types of frictional forces. Activity: finding the maximum frictional force exerted on the object. So, for this activity, we need two main materials. One is a wooden cube. It can be a cuboid shape or it can have different faces. Both are fine. So, it can have all similar faces or it can have different faces, but the surface has to be smooth and even. So, we need a wooden cube or a wooden block. I can say wooden cube or a wooden block. And to this wooden block, we will have to attach a hook. We will attach a hook to this wooden cube. And we need a surface, a horizontal surface where we keep the wooden block and we need to pull it along that horizontal surface. So in addition to this, we need a horizontal surface. We will need a horizontal surface. So maybe a table which is horizontal, which is even and flat. And then to measure the force that we are applying and to determine the different frictional forces, we will need a Newton balance or a spring balance. This can be a Newton balance or it can be a spring balance. Either balance is okay. So what we will be doing is, we will first fix the hook to the wooden block. Then we place the block on a horizontal surface. And then we connect this hook of the Newton balance to the hook attached here. And initially, we apply a small force and we try to pull the block. You will see that the block will not move. Then we try to increase the force that we apply. And observe what happens. If the block doesn't move, we increase the force further. So we keep on increasing the force until the block just starts to move. And then at that moment, you can get the Newton balance reading. Or if you are using a spring balance, you can get that reading in grams. You can either get the reading in newtons or in grams. So from that, we can determine how the frictional force changes when an object is trying to move and when the object is moving. Let me summarize this method again for you all, and after that, I will do the activity in the lab. The method. So here, it's more clear to you when we use a diagram. This is the block of wood and it is there on a table, and as I told you, it has to be a horizontal table. Now you might be wondering why it has to be a horizontal surface. Now if it was a slope, then the slope can change the way the block moves. So if it is a horizontal surface, then the movement will not depend on the slope because it's going to be a flat surface. The Newton balance is attached to the hook that is fixed to the block. So let us look at the steps. Fix a small ring to the block of wood and attach the balance to the ring. The first step. Place the block of wood on a horizontal table. Pull the block with a very small force. You would be able to read the magnitude of the applied force from the Newton balance. So here we can read the magnitude of the applied force. You don't have to write down all the forces, but you need to write down the force just when the block starts to move. Initially, the force would be insufficient to move the block. So it will not be enough to move the block. Why? The frictional force is balancing the applied force. Gradually increase the force on the object. When the force is gradually increased, at some point it will just begin to move. So here you can see it will just begin to move. Find the force at the moment it is just about to move. As the object starts to move, you have to find the force. So this is a very simple activity. Only thing, you have to have a horizontal surface, a wooden block and a Newton balance attached to the wooden block. So that you have understood this activity clearly. Now let us do this activity in the lab. Okay students, now we are going to do this activity to observe the static frictional force, limiting frictional force and the dynamic frictional force. As you can see, we will need only two objects to do this activity, a wooden block to which a hook is already attached so that it's easy for us to connect the Newton balance to the block. And as you can see here, there is the Newton balance which has the readings in Newton. If it is 1 Newton, that is equivalent to 100 grams. So we can apply the force by pulling the Newton spring balance. So for the start of the activity, I will apply a small force on this wooden block by pulling the Newton balance. Then you can see the observation, the change that is going to take place. Here as you can see, initially the reading shows 0 Newton and when I increase it, it comes to 0.5 Newtons, then 1 Newton, up to 1.5 Newton. When I apply the force, the wooden block did not move. So from this observation, you can understand that when I apply an external force, that force is being balanced by the force that is exerted by this surface. That is what we call as the frictional force. And since the object is not moving, it is the static frictional force. And when I keep on increasing the applied force, the static frictional force also increases. But that has a limit. Once it reaches the maximum limit, we call it the limiting frictional force. And thereafter, we'll see what happens if I apply more force. Now again, I'll start from 0 Newtons. You can see it's coming to 100, then up to 150 grams, that means 1.5 Newton. And further when I increase it to 2 Newtons and more than 2 Newtons, when it is almost 2.5 Newtons, you can see the block is moving. So that means students, up to 2.5 Newton, when we apply the external force, that is being balanced by the static frictional force. So there, the 2.5 Newton becomes the maximum value for this force when the object is not moving. That is the limiting frictional force. Thereafter, the block started to move. The surface exerts a force on the block. That is why the block did not skid off the table, but it moved continuously. So that force, the force exerted by the surface of the table on a moving object, is known as the dynamic frictional force. So from this activity, you have observed clearly, until 2.5 Newtons, there was no movement on the block. That means there was a static frictional force and it reached the maximum value 2.5 Newtons. That is the limiting frictional force. And finally, when we applied force greater than 2.5 Newtons, the cube was moving and on the wooden block, there was a friction being exerted. That is the dynamic frictional force. So with this, you have clearly observed the three types of frictional forces. Okay students, you all observed the activity that we carried out just now to see what the three instances of frictional force are. So in that activity, the observations that we noted down are the readings of the Newton balance. Initially, when you apply a force, the block did not move. And at that time, you saw the Newton balance reading. It was less than 2.5 Newton. So if we write down the observations, that will be the Newton balance reading. So the first reading is that I can say less than 2.5 Newton, block doesn't move. Then you saw clearly when the block just started to move, the Newton balance showed a reading of 2.5 Newton. So that was the second observation you all saw. So the second one, 2.5 Newton when the block just starts to move. Thereafter, you saw the Newton balance reading when the block was moving. That was also slightly less than 2.5 Newton. So then, slightly less than 2.5 Newton when the block is moving. So these are the three observations that you saw from the activity, and these correspond to three different instances of frictional force. We apply a force, but that force is balanced by the frictional force. Then the object will not move. That is the first one. That frictional force is called the static frictional force. So that is one conclusion that you can get from this activity. So the first conclusion, the friction acting against the motion of an object when a force is applied and the object is at rest, or you can say just before it starts to move. Before it starts to move. This is known as the static frictional force. The first instance, static friction. Then we have the second instance, the maximum frictional force exerted by the surface against the movement of the object. That is what we get as 2.5 Newton, and this is called the limiting frictional force. So the second conclusion is that maximum friction exerted by the surface against the motion of the object. Then we call it the limiting frictional force. So this will be limiting friction. And in this activity, we got the value for limiting friction as 2.5 Newton. That is when the block just starts to move. If you look at it closely, students, when we exceed the limiting frictional force only, the block will start to move. But when we do the activity, it is difficult to measure the limiting frictional force. So therefore, approximately, we take the Newton balance reading when the block just starts to move as the limiting frictional force. So here it is 2.5 Newton. And when the block is moving, still the surface will exert a friction against the movement, and that is known as the dynamic frictional force. So that is the next one. Friction exerted by the surface against the motion of an object. This is known as the dynamic frictional force. Dynamic friction. So from this activity, we have observed the three different instances of frictional force: static friction, limiting friction, and dynamic friction. Let us define these instances once again. Static friction, limiting friction, and dynamic friction. So now you're very familiar with all three states of friction. When an object is trying to move relative to the contact surface, the friction exerted by the contact surface is known as static friction. That is when the object is unable to move. So here I can write it as the friction exerted by the contact surface against the relative motion of the object. So this is the friction that is known as static friction. So that is when the object is not moving. So here I can say object is not moving. Then we saw what limiting friction is. Limiting friction is the maximum frictional force that can be exerted by a contact surface against the movement of an object. So here I can say the maximum friction that can be exerted by the contact surface against the relative motion of the object. So this is when the object just starts to move. So here object just starts to move. And finally, the third type, the friction exerted by the contact surface against the motion of a moving object. So here the friction exerted by the contact surface against the relative motion of the moving object. So students, now you have a good understanding about what friction or frictional force is and the three states of friction or frictional force: static friction, limiting friction and dynamic friction. Now let us discuss the factors that affect friction. Factors affecting the limiting frictional force. So as you have already understood, students, the maximum frictional force that can be exerted by a contact surface against the movement of an object is the limiting frictional force. And this depends on three factors, or we can check and see whether these three factors affect the limiting frictional force, because this is exerted by the contact surface. So therefore, the nature of the contact surface will have an effect on the limiting frictional force. So that is one factor that we need to check: nature of the contact surface. We discussed one example at the beginning. A floor, a normal floor, you walk without slipping. A floor that is wet, the nature of the contact surface changes. We tend to slip. So we will see how the nature of the contact surface affects the limiting frictional force. Then because it is the contact surface, if it's a small object, the frictional force can be one type. If it is a large object, the frictional force can be a different type. That is what we expect to see. So let us also check whether the cross-sectional area or the area of the contact surface affects the frictional force. So that is the second factor we need to check. So here I will write down area of the contact surface. So now I am writing down the factors that can possibly affect the limiting frictional force. We are not concluding that all these factors affect the frictional force. The third possible factor is the perpendicular reaction. I will explain what this is. Perpendicular or normal reaction. So this is another factor that might affect the frictional force. Now when there is an object placed on a surface, the weight of the object acts downwards and there is a reaction given by the surface against the weight of the object. That reaction is known as the perpendicular reaction or the normal reaction. So when the weight of the object increases, the perpendicular reaction will also increase. Now let us check whether these three factors affect limiting frictional force. So we will start off with the first factor, nature of the contact surface. Investigation of the influence of surface roughness on friction. This is where we talk about nature of contact surface. So to observe this effect, we need to have different types of surfaces or surfaces that are different in roughness. So the ideal material to get different roughness is given to you here. These are sandpapers. You all know the use of sandpapers. They have a rough surface. We use them to polish surfaces, maybe to polish wood or polish surfaces. So these sandpapers can be obtained in different roughness. So sandpapers with different roughness. Then we need to use a wooden block. So a wooden block will be the object that is trying to move on a surface. So as I said before, we will need a horizontal surface. And what are we going to do? We will fix a hook to this wooden block so that we can connect the Newton balance. And the Newton balance is to read the force that is applied. Newton balance. So again, this is a very simple activity. We will first start with the sandpaper with the least roughness. What we have to do is we have to paste the sandpaper to the surface of the wooden block. Then place that surface on a horizontal surface, a horizontal table. And already we have a hook attached to it. You fix the Newton balance to the hook and we apply a small force and try to pull the block. It won't move. We increase the applied force and as the block starts to move, we write down the Newton balance reading. And from the previous activity, you know the Newton balance reading gives you the limiting frictional force because that is the force needed to just move the block. Then we repeat the activity with a sandpaper with a slightly higher roughness. If you have more than 2 types of sandpapers, you can repeat it again and again and get the reading of the limiting frictional force. This is one way of doing this activity. Or else what we can do is we can paste the sandpaper on the table and try to pull the block on it. In the first procedure, I told you all we have to paste the sandpaper to one of the surfaces of the wooden block. We can do it in a different way. We can paste the sandpaper on the table and pull the wooden block on it. Both methods of doing this activity will give you the same observation. So let me first summarize the method or the procedure once again for you all. The method, as you can see here, the block of wood is shown and the rough sandpaper, initially we start with the least roughness, is pasted to the block and the hook is shown there and the Newton balance is attached there. And you have to pull the block with a horizontal force. The force has to be given parallel to the horizontal surface so that the block does not move in any other angles. It moves along the table when you apply a horizontal force. So we can look at the steps. Fix the block of wood with the sandpaper having the lowest roughness with the rough side facing out and completely covering the bottom surface. Place the block of wood on the table so that the rough surface of the sandpaper is in contact with the surface of the table. So that is what is shown in the diagram. Next, pull the Newton balance attached to the block with a very small horizontal force. So this I have told you all, the horizontal force is to make the block move horizontally without moving in any other directions. Force at first and then increasing the force gradually. So initially we apply a very small horizontal force and then increasing the force gradually. When the block of wood just begins to move, record the reading of the Newton balance. This is the limiting frictional force. This is the limiting frictional force. Next, use a sandpaper which is rougher than the first and fix it again to cover the bottom surface of the block. And find the limiting frictional force that is just enough to set the block of wood in motion. So we repeat the same activity with different types of sandpaper. Repeat the above procedure using several sandpapers of increasing roughness and record the limiting frictional force each time. Compare the results you obtain. So when we compare the results, we will know how the nature of contact surface affects the limiting frictional force. So this is again a simple activity. Let us now carry out this activity in the lab. Okay students, now let us do this activity to observe the effect of nature of surface on limiting frictional force. So as you can see students, we have two sandpapers, one with less roughness and the other one with more roughness. You can even use more than two papers, but here for the demonstration, I'll be using only two types of sandpapers. We have done this activity before. We will be using this wooden block as the object and the Newton balance. So I will place the wooden block with the Newton balance attached to it, and when I pull the block, you can observe the Newton balance reading, and that will be the force that is needed to move this wooden block. So here you can see whether it changes with the nature of the surface. That is the roughness of the two sandpapers. So now we are doing it with less roughness. You can see when I apply a force, when it comes to 2 Newton, still no movement, but when it goes above 2.5, almost like 2.8 Newton, the block moves. So the force needed to move this object from rest on this less rough surface is about 2.8 Newtons. Now, the same activity we will repeat with the second type of sandpaper, the sandpaper with a little more roughness. So, I will place the same wooden block here, and again I will try to pull the wooden block. So, you can observe the reading, that is the force needed to move the object on this surface. So here, as you can see, when I keep on increasing the force, it's not moving, and above almost 3 Newtons, a little more than 3 Newtons, the block is moving. So on this surface, you saw that with about 2.8 Newtons, the block moved, and here a little more rough surface, we needed to apply more than 3 Newtons. So that means when the roughness increases, the frictional force increases. Therefore, the force that we need to apply also increased. So students, by observing this activity, you can understand the effect of nature of surface on limiting frictional force. When the roughness increased, the frictional force increased. Okay students, so you saw how the force needed to be changed when we did the activity. If you can remember from the previous activity, when there was the wooden block on the table, we applied 2.5 Newton just to make the block move. As it just started to move, the reading of the Newton balance was 2.5 Newton. So that is the first observation. So I will write down the first observation. Only the table surface we needed 2.5 Newton when the block just started to move. And when we use the sandpaper with the least roughness. So for the sandpaper with low roughness or less roughness, you can say, we needed to apply 2.8 Newtons. You were able to observe that during the activity. So the force required was 2.8 Newton. And during the third instance, we used a sandpaper with a higher roughness. Then the Newton balance reading was 3 Newton as the block just started to move. So here, sandpaper with high roughness, it was 3 Newton. All these are when the block just starts to move. So this was the observation of the activity. Different surfaces, different limiting frictional forces. Only the table surface limiting frictional force is 2.5 Newton. Slightly rough surface limiting friction is 2.8 Newton. And a rough surface or high roughness, the limiting friction is 3 Newtons. So from that we can conclude by saying when the roughness of the surface increases, the frictional force or the limiting frictional force exerted by the surface will increase. So here the conclusion will be when the roughness of the contact surface increases, the limiting frictional force increases. So that means the nature of the contact surface affects the frictional force, and when the roughness increases, the limiting frictional force increases. So in other words, I can say nature of the contact surface affects the limiting friction. So this is the conclusion that we can obtain from the first activity. Now let us do another activity to check whether the area of the contact surface will affect the limiting frictional force. So let us discuss that activity first. Investigate the dependence of, again, the limiting frictional force on the surface area of the contact surface. So for this we will need these materials. In this first picture you can see there are 3 wooden blocks shown to you. That is to indicate that we need a wooden block with different area of contact surface. So it cannot be a cube. It has to be a wooden block which has different areas. The faces have to have different surface areas. So I can write down a wooden block with faces of different surface area. So you need to have 3 different surface areas or at least 2 different surface areas. So if it is a rectangle large surface area like this, then we can have another small surface area and another smaller surface area on the other face. As before, we need a Newton balance to get the reading for the limiting frictional force. And to attach the Newton balance to the wooden block, we will have to attach a hook to the block. So, and this hook has to be attached to all three different faces of the block. And also, to make the surface rough, we will be needing sandpapers. Sandpapers. So again, we do the similar activity where we attach a hook to the face of a wooden block and we need to paste the sandpaper covering the surface of the wooden block. Here we have to cover three different faces with three different surface areas. As I mentioned before, we can either paste the sandpaper to the wooden block or we can paste the sandpaper on the table. Either way, you will get the same observation. So, once the sandpaper is pasted to the table, we place the wooden block with the largest face contacting the surface of the table or the sandpaper pasted on the table, and then we attach the Newton balance to the hook. We apply a force. Initially it won't move. We increase the force gradually and note down the Newton balance reading as the block just starts to move. And also we have to apply a horizontal force so that the block moves along the horizontal table or the horizontal surface. Then we repeat the procedure with a different face having a different surface area. So in this cube, you can see there are three different faces with three different surface areas. So you can repeat the procedure 3 times with the 3 different surface areas of the contact surface and observe whether the limiting frictional force changes or whether it remains the same. Now let me summarize the procedure once again. The method, as you can see in this diagram, the different surface areas of the different faces are labeled as A, B and C. You can see the surface area A is greater than C and that is greater than B. B has the smaller surface area and A has the highest surface area. So, if we use these 3 blocks, then we can carry out this activity and observe how the limiting frictional force changes or whether it does not change. Paste the sandpaper on the surfaces of the block of wood which have different areas. Next, place the surface with the largest area in contact with the table and find the force that is just enough to move the block of wood. The limiting frictional force. As before, repeat the above step placing different surfaces of the block in contact with the table to find the limiting frictional force corresponding to each surface. So, I have explained the steps of this procedure. I am sure you would have understood it clearly. It is a very simple activity. Now, let us do this activity in the lab. Okay, students. Now, let us do the activity to observe whether the surface area of an object has an effect on the limiting frictional force exerted by the surface of the table. So, for that, I will need a wooden block like this. This block has different surfaces. As you can see, this is a surface which has a high surface area. You can look at this surface, it's a larger surface area. At the same time, we can use this other surface which has a smaller surface area. But it is the same block, the small surface area and the large surface area. I'll be using both the surface areas. So here as you can see, this side and this side both have the same surface area and the same texture. So there is no other effect on the frictional force. So first I will place the larger surface area on the table, and to that I will connect the Newton balance to the hook. And then when I apply the force, you can see and observe the force at which the block starts to move. So you can see here when we apply the force gradually, I have already explained to you in the previous activities as well. The Newton balance has Newton reading, and if it is 1 Newton, that is equivalent to 100 grams of force. So either way, you can observe the force exerted on the block. Now observe what happens when I apply a force. You can see the force increases. When it reaches above 2.5, you can see wooden block is moving. So there we can see that the frictional force, that is the limiting frictional force exerted by the surface when it is the large surface area is 2.5. So now I am going to change the surface area of the block. As you can see, this is a smaller surface area, and this surface and the surface that is in contact with the table are the same. So that has a smaller surface area compared to the previous instance, that is this surface. So now if we try and apply the force, you can observe when the block starts to move. So here as you can see, when it is close to 250 or 2.5 Newton, the block moves. So as you know students, although we expect an exact value of force for both the surface areas, there can be slight differences in the surface of the wooden block and the surface of the table. Therefore, we get approximate values. But in both instances, you saw that the force that was needed to move the block was 2.5 Newton or very much closer to 2.5 Newton. So that means the surface area, the area value, the magnitude of the surface area does not affect the limiting frictional force. It is the same as long as the object is the same and the surface that exerts the frictional force is the same. So you have observed this activity and now you know that there is no effect of surface area on the limiting frictional force. Okay students, so you saw the observations of this activity clearly and you saw what happens when we change the surface area of the contact surface. The force does not change. As we saw before, we used a different cube and we used the different surface areas. Still the limiting frictional force that was read from the Newton balance reading was the same value. It was equal to 2.5 Newton. So here the observation is with different surface areas, the Newton balance reading when the block just starts to move was 2.5 Newton. So that means the limiting frictional force was 2.5 Newton during all different instances. So the limiting frictional force did not change with the area of the contact surface. So that means the surface area of the contact surface does not affect the limiting frictional force. So here this value is the limiting frictional force. Limiting friction or the limiting frictional force. So therefore we can conclude by saying the limiting friction did not change with different surface area in contact. In other words, we can say the surface area of the contact surface does not affect the limiting friction. So students, we discussed 3 factors that can possibly affect the limiting frictional force. And out of those, we investigated the first 2 factors. And out of the 2, the nature of the surface area affects the limiting frictional force, but the surface area of the contact surface does not affect the limiting frictional force. Now there is one more factor, that is the perpendicular reaction or the normal reaction of the object. That depends on the weight of the object. Let us now discuss the activity where we investigate the effect of perpendicular reaction on limiting frictional force. Investigation of the dependence of normal reaction between bodies in contact on the limiting frictional force. Normal reaction and perpendicular reaction are both the same. So here we can use the other term, perpendicular reaction. Both are same. So we will see whether this affects the limiting frictional force. So for that we will need 3 wooden blocks. Blocks of the same weight, or you can use one block and other objects with different weight. So here we will be using 3 wooden blocks. So they are similar wooden blocks. They are not identical, but they are similar. And as we have done before, we will need to attach a hook to one of the wooden blocks. We don't need to attach hooks to the other blocks. And to read the limiting frictional force, we need a Newton balance. and also we will need a horizontal surface to do this activity. Here we don't need a sandpaper. Again, it's a very simple activity. You place the wooden block with a hook attached to it on a horizontal surface, a table, and to the hook you attach the Newton balance, and by pulling the Newton balance horizontally, apply a force to the block. Initially the block will not start to move. We increase the force and get the Newton balance reading as the block starts to move. In the second step, we place another block on top of the first block and repeat the activity. Pull the blocks and get the Newton balance reading as the block starts to move. In the third step, we place the third block also on the other two blocks. So we have all three blocks, one on top of the other. Then we try to pull the block that is at the bottom with the Newton balance, and as it starts to move, we get the reading of the Newton balance. So in each instance, we are getting the reading of the Newton balance that is equal to the limiting frictional force. Then we can compare whether the normal reaction, perpendicular reaction, affects the limiting frictional force. As you can see, when we increase the number of blocks, the weight of the block increases and therefore the perpendicular reaction increases. Let me summarize the steps again. The method, here it is shown to you in the picture. Only one block placed on a horizontal surface and we are pulling it with a horizontal force. You find the limiting frictional force, then two blocks and all three blocks. We can also do this activity with different objects placed on the first block. So place one block of wood on the table and find the force required to just move the block. That is the limiting frictional force. Next, place another block of wood on the first one and find the limiting frictional force as before. Repeat the above step with the third block placed on the other two and record the limiting frictional force. And note, this experiment can also be done by placing various other objects on the first block of wood instead of the other blocks of wood. So here we just want to observe whether the perpendicular reaction affects the limiting frictional force. So therefore we can use different objects. It would be better if we use objects of different weight. Then you can understand the effect easily. So students, you have understood the steps of this activity clearly. Now let us do the activity in the lab. Okay students, now let us do this activity. Here we are going to observe the effect of perpendicular reaction on the limiting frictional force. So when we say perpendicular reaction, when there is an object at rest on a surface, the weight of the object acts downwards and the perpendicular reaction is against that. So then the object is at rest under balanced forces. So when we increase the number of blocks, we are increasing the weight of the blocks, that is the total weight increases and therefore the perpendicular reaction will increase. So for this activity, I'll be using three similar wooden blocks with equal masses so that we can gradually change the perpendicular reaction. And to apply and determine the force applied, we use the Newton balance. and you are already familiar with the Newton balance. It has the gram reading as well as the Newton reading. So for this block, I connect the Newton balance and apply a force and note down the force that is needed to move this wooden block. That will give you the limiting frictional force. So as you can see, when I increase the force little by little, you start from 0 and the force increases. When it reaches 1 Newton, the block starts to move. And with 1 Newton, the block can move easily. So that means when we use one block, the limiting frictional force is less than 1 Newton, and therefore when we apply 1 Newton force, the block starts to move. And when the block is moving, there is a dynamic frictional force acting on it. But here we are going to see how the perpendicular reaction affects the limiting frictional force. So for that, I place the second wooden block on the first block. So the weight of the cube increases, therefore the perpendicular reaction increases. Now when we connect the Newton balance and apply a force, observe the force needed to move the objects. So here you can see at 1.5 the blocks have not moved. But when I apply a force of almost 2 Newton, the block is moving. That is, the two blocks combined together move with a force of 2 Newton. Earlier it was 1 Newton, now it is 2 Newtons. And for the next activity, the next part of the activity, we use 3 wooden blocks. So here we have increased the perpendicular reaction further. And now when I try to apply the force, you can observe I increase the force to 1.5, 2, no movement, 2.5. When it comes to almost closer to above 2.5 and between 3 Newtons, the blocks are moving. You can see slightly there is a difference between the 3 blocks. Therefore, the perpendicular reactions of the 3 blocks are not exactly equal. Therefore, you can observe an increase in the force needed to move the blocks, but it does not increase with the same magnitude. So, from the activity you have observed, when we increase the perpendicular reaction, the force needed to move the blocks increases. That means the limiting frictional force exerted by the surface increased. So therefore, perpendicular reaction is directly proportional to the limiting frictional force exerted by the surface. Okay, students. So you observe the activity clearly. Always the Newton balance reading when the block just starts to move is the limiting frictional force. And here we wanted to study the effect of perpendicular reaction on limiting frictional force. I will write that down first. Newton balance reading when the block just starts to move equals limiting friction. So there were 3 instances under which we determine the limiting friction. With 1 block, with 2 blocks and with 3 blocks. So when we used only 1 block, what was the Newton balance reading as the block just started to move? It was 1 Newton. Then we increase the blocks to 2 blocks. Then the Newton balance reading was 2 Newton. Finally, we used 3 blocks. 3 blocks kept one on top of the other. And the Newton balance reading as when the block just started to move was 3 Newton. So from this, what can you understand? When we increase the number of blocks, the weight of the block increases. What is the other factor? The normal reaction or the perpendicular reaction increases with the increase in weight. So when there is 1 block, there is 1 unit of perpendicular reaction. 2 blocks, 2 units of perpendicular reaction. 3 blocks, then there are 3 units of perpendicular reaction. And with that, the limiting frictional force increased. So that will be the conclusion of the activity. So here, conclusion, when the weight of the object was increased, the normal reaction increased. With that, the limiting friction also increased. So this is the conclusion of the activity. But if we put it in other words, we can say the increase in normal reaction increases the limiting frictional force. Or you can say the normal reaction or the perpendicular reaction affects the limiting frictional force. So I will include that as well in the conclusion. So here we can say when normal or perpendicular reaction increases, the limiting friction increases. So that is the conclusion we can draw from this activity. The above activities show that the limiting frictional force depends on the nature of the contact surfaces and the normal reaction between the surfaces, while it does not depend on the area of the contact surface. Does not depend on the area of the contact surface. So this is what you have to remember. So now that you have a good understanding about friction, let us discuss the applications of friction. Practical applications of friction. Now in day-to-day life and also in industrial processes, we use lot of instruments and machines. Inside these machines, there are many parts that move relative to each other. parts that are in contact with each other and they move one on top of the other or relative to each other. Then there will be friction between the contact surfaces. Now this friction causes loss of energy because when the surfaces move one on top of the other due to friction, additional work has to be done against friction. And this additional work is a loss of energy. So when that happens, there is lot of heat generated in the machine. So we need to take measures to cool down the machine, and also due to friction, the parts of the machine can wear off very easily. If we know the methods of reducing friction, then we can reduce this energy loss, and also we can prolong the wearing off of parts of machines. So I will summarize that here. Parts of machines move relative on one another. So if they are in contact and one is moving this way, the other one is moving this way, they are moving relative to each other. So here, due to friction, a lot of work is done against friction. This leads to energy loss and also wearing off of parts of machines. And if we can reduce this effect, then we can save a lot of energy. That can be done by reducing friction. So let us now discuss how we can reduce friction. Methods of reducing friction. So here we know the factors that affect friction. If we can change the factors, obviously we can't change the perpendicular reaction or the normal reaction of an object because we have to have the same object for a certain purpose. The change that we can do is to the nature of the contact surface. As we discussed before, when the surface becomes smoother, the friction decreases. So, if we can make the surface smooth, we can decrease the friction. So, here the first method is to make the surface smooth. This can be done by polishing the surface. As an example, you can consider a rough floor. It will be difficult to walk. If you polish the floor, if it becomes smoother, then it will be easier to walk on the floor. But if it becomes too smooth, or if there is oil on the floor, then you can fall because there will be very less friction. So by making the surface smooth, we can reduce friction. And I said when there is oil on the floor, we can slip. Oil is a type of agent that can reduce friction. This is called a lubricating agent. So by applying lubricating agents, we can reduce friction. So we apply oil, that is lubricating oils, grease, graphite to parts of machines to reduce friction. So the second method of reducing friction is to apply lubricating agents. Examples are graphite, grease, and lubricating oils, or what we call as lubricants. Lubricating agents are also known as lubricants. So by applying lubricating agents, we can reduce friction. The third method of reducing friction is to insert bearings. It can be of different types. Two common ones are ball bearings and roller bearings. These are balls. Ball bearing means balls inserted between surfaces that are moving relative to each other. If you can remember, students, you would have seen this in day-to-day life as well when we discuss the Newton's laws of motion. There is an example where two boys are sitting on wooden planks and they try to exert a force by pushing each other with their palms. But they move away. And when they move away, it is easy to move because the wooden planks have wheels on it. These wheels help the plank to move easily. If there were no wheels, it would have been difficult for the planks to move away. Same way, if you take roller skating shoes, they have wheels. So there, it's easy to slide on a surface when you wear roller skates. The same principle is used here. That is the third method, applying bearings or using bearings. Using bearings. Ball bearings, or roller bearings, and these are small balls inserted between contact surfaces or small rolls that are inserted between contact surfaces, and this is most commonly used in parts of vehicles and machineries when there are moving parts as well as in axles. So this is used in moving or rotating parts of vehicles and in axle. So now students, let us look at these types of bearings that are used in different machines. In these pictures, you can see this is what we call a ball bearing. So here there are small balls inserted between. This is one surface, this is another surface which are moving relative to each other, and inside there are balls. So these balls make it easy for the contact surfaces to move because the balls also can rotate and make it easy for the surfaces to move. That reduces friction. Here you can see roller bearings like small barrels. The rollers are there. They also help the contact surfaces to move easily one on top of the other. And here you can see a part of a machine. The green color is one surface and the silver color is another surface. In between there will be ball bearings or roller bearings. So the surfaces can rotate one on other with less friction. So these bearings help to reduce friction in parts of machines. Now let us discuss the uses or advantages of friction. Advantages of frictional forces. We can walk on a surface without slipping. So this is an example that we have been discussing many times. When we walk on a floor, we walk without slipping because of friction. We have markings on our sole. So if you walk with barefoot, they increase friction, the friction between the floor and your feet, and it helps to walk without slipping. When you wear shoes or slippers, there are markings on the slippers that help us to walk without slipping. That is why when there is oil on the floor or when the floor is wet, the water, oil, they act as lubricating agents, what we discussed before. So they reduce friction and we tend to fall easily or we tend to slip quickly. Second one, grooves etched on tires of vehicles help prevent the vehicles from skidding. So grooves etched on tires. Here you can see these are the markings that are known as the grooves. So these are there on vehicle tires, the surface of the vehicle tires. These are there mainly to allow water to flow through it when the vehicle is moving on a wet road. And also these grooves make the vehicle tire, the surface of the tire, rough. So that increases friction. Therefore, the vehicle can move on the road without skidding. Help prevent skidding. So it prevents skidding. Then the third advantage, fibers of a coir rope don't separate off easily even if a large force is applied. Fibers of a coir rope. You all know what coir is. We obtain coir from coconut husk and it is a rough substance. It's a rough fiber. So when many of these fibers are bound together because of the friction, they stay together and they are very strong. So even when you pull the rope, the fibers don't separate out easily. So if we use a coir rope and a nylon rope is very smooth. The friction is less. So it can come off easily. But a coir rope doesn't come off easily. And also the fibers don't separate out easily. So that is again an advantage of frictional force. Let us discuss a few more advantages. Can stop a moving vehicle by applying the brakes. So when we say brakes, you can see in the picture brake of a bicycle and a brake system of a car or a vehicle is given to you. So here there are two types, the brake of the bicycle and the brake of a motor vehicle. Here you can see in this picture, these are brake pads, what we call as brake pads. And these brake pads are made up of rubber. And when these brake pads are new and not worn off, they have a very rough surface. So when you apply the brake from the handlebar, the connecting wires act on the brake pad and these two brake pads go and touch the rim of the wheel. And when the surfaces are rough, there is high friction. That friction helps to stop the moving bicycle. But if the brake pad, the rubber pad wears off, it becomes smooth, then you will not be able to apply the brake efficiently. So you have to make sure your brake pads are in good condition so that you will be able to stop the bicycle on time. The same way in motor cars, you can see these are the brake pads. The blue color parts are the brake pads. They are again rubber pads. And this is a disc, the silver color, the circular structure is a disc. And this is a disc brake system. A disc brake system. Here also, when the brake is applied, the brake pads come and hold or touch the disc. That is this part. And when they are very rough, they can hold the disc together without moving due to high frictional force. And this helps to stop the vehicle because the wheels are attached to this part. And when the disc, the rotor is not moving, the tires also will not move. So then the vehicle will stop. So to stop the bicycle or a motor vehicle, a motor car, by applying brakes, we need to have enough friction. So that is also an advantage of friction. So students, now you have a good understanding about what friction is, the three states of friction, static, limiting and dynamic friction, and also how the factors that affect friction and how friction can become an advantage as well as a disadvantage. And to reduce this disadvantage, the methods we can use to reduce friction. So let me summarize what we have discussed so far. Summary. When one of two bodies in contact with one another moves or tries to move relative to the other, the second body exerts a force that tends to stop this relative motion. This phenomenon is known as friction. So here we need to have contact with one another. There should be two surfaces. When one tries to move on top of the other or relative to the other, the second surface exerts the frictional force. The frictional force that acts before the body begins to move is the static friction. The three states. Static friction between the bodies vary with the external force that tries to cause the relative motion. When we apply a small force, static friction is less. When we apply a higher force, static friction is higher. And it reaches the maximum value, then it becomes limiting frictional force. The frictional force that acts when the relative motion between the two bodies just starts is known as limiting frictional force or limiting friction. Limiting friction between two bodies depends on the nature of the contact surfaces and the normal reaction. So, the two factors that affect the limiting frictional force. Limiting friction does not depend on the surface area of the contact surface. So, two factors affect it. One factor does not affect the limiting frictional force. The frictional force acting on a moving body is the dynamic friction. So, this is the summary of what we have discussed so far. So, students, we come to the end of discussion on friction. I hope you have understood all the facts related to friction and you will be able to answer questions. We will start off with the questions given in your textbook. So, before you listen to the discussion, you all read the lesson once and answer all the questions. Then you can check your answers with my discussion.